So this is the lesson 4 video for the adapted booklet. These notes should go with your booklet notes. Again, if they don't match up, you probably opened the wrong video. And so for this video, we're going to look at chords inside of a circle. So you should have already drawn a chord onto your word wall. But now I need you to add a perpendicular bisector to your chord. And so a perpendicular bisector is a chord. So there's our chord. And the chord is being cut by a radius line. And it's perpendicular, so that means that it's 90 degrees. And it's a bisector, meaning that it cuts it into 2 equal pieces. Okay, so that should be added onto your word wall. So the first example we're going to do is we're going to look at bisecting a chord with a radius. And so it says we have a radius CD bisects chord AB. We know that the chord is 8 centimeters. So from A to B is 8 centimeters, so that means each half is going to be 4 centimeters. And the radius is 5 centimeters. So then we want to know what is the length of this segment. So it's not the same as the radius because CD is the radius, so CE has to be shorter. And so we need to use Pythagorean to kind of help us figure this out, because we know that it's a perpendicular bisector because it's a radius line with a chord. So CD is a radius that bisects the chord AB. So it is perpendicular to AB. A perpendicular bisector makes a 90-degree angle. So angle AEC is 90 degrees. AEC is 90 degrees. CD divides AB in half, so each side is equal. So each side, and we already said this, is 4 centimeters. So knowing that and knowing the radius, we can use the Pythagorean relationship to find this side. So again, with the Pythagorean, we make sure we have a right triangle, which we do. We shoot an arrow through our 90-degree angle to point to the hypotenuse. So we know the hypotenuse, but we don't know the other 2 sides. So again, I'm just going to label them off to the side. You can write in the boxes if you want. I think this is a bit better. So we know the hypotenuse. We need to find one of the shorter sides. We're going to subtract. So hypotenuse squared, take away the side that we do know, will give us the side that we don't know. And so the hypotenuse is 5. So 5 squared, take away 4 squared will give us our side. 5 squared is 5 times 5. Take away 4 squared, which is 4 times 4. And so then we're going to subtract them. And we get 9 equals the area. I don't want to know the area. I want to know the side length. So we need to square root. And we get 3 centimeters. So that means from C to E is 3 centimeters. And we knew it had to be less than the radius, right? So the length of CE is 3 centimeters. The next, they could also give you kind of a tricky question here, and they could say, well then what's this length? Well, hopefully we notice that we could take the radius, so 5 centimeters, take away that piece we just found, and so we could figure out that that piece is 2 centimeters. So D to E is 2 centimeters. So just kind of some of the tricky things they might ask you to do with circles, or that you can do with circles. Okay, sometimes we have to solve problems. I know, right? So this one says, Louise wants to drill a hole for an umbrella in a circular table. So she wants to put it in the middle. How can she find the center? So this is how you can do it. And I actually didn't know how to do this before, so I thought that this is kind of a cool trick to learn. So the first thing you need to do is just draw 2 chords. So you can draw them anywhere you want on the circle, as long as they're not diameter line. So draw 2 chords, find the midpoint of each chord. Okay, so you could either fold them or you could measure. So find the midpoint of each chord after you've measured it, and then you just make a little dot. Then you're going to use a right triangular ruler or a protractor, that's the word I was looking for, to bisect each chord. Okay, to make the bisector. So we want to draw them at 90-degree angles, and we need it to cut each chord in half. So hopefully you're doing this on your paper, and me doing it on here is not going to be quite the same, but I'll try my best. And so that's about the middle, 90-degree angle bisector, and then here. Okay, and so the point where they cross will be the center of the circle. Crazy, right? So that's it for this lesson. If you have any questions, we can go over them together in class, but then this is your assignment. Okay, a little bit of page 14 and then page 15, and then you're done.